Alright, see what we got here. Maximum side length of a square with sum less than or equal to threshold. Given an m by n matrix mat, an integer threshold, return the maximum side length of a square with a sum less than or equal to threshold, or return 0 if there is no such square. Maximum side length of square with sum less than or equal to, okay, sure. So here the threshold is 4. So you could do a 2 by 2 here, and that would work, or 2 by 2 here. Okay, I assume that they just thought this is simple enough of an explanation or a description that needs no really interesting examples. So if the threshold was something bigger, let's say it was 50, then you might be able to do a 3 by 3 because everything inside the 3 by 3 is less than 50 added together. Alright, this is very similar to the one from yesterday in the sense there's a lot of summation of things. I don't know if I use a prefix sum here though, or prefix arrays to calculate sums quickly here. Can I? Let's go ahead and consider the sizing here. It's 300 by 300. 300 by 300. So what can you do? So if it's 300 by 300, you first look at maybe adding all the elements in 300 by 300. If the sum of all those things is less than that threshold, then you just return 300. And then if it's 29 or 299 by 299, there's like maybe 4 possibilities. So like you kind of remove maybe the bottom row and the rightmost column and check there, or you remove the bottom row and the first column. Uh, 300 by 300. So this is big enough that I don't think you can do an n squared approach here, because that'd be 300. Yeah, I don't think you do an n squared approach. That's probably too much. That ends up being, well, n squared might be okay, but if you do, when I say n squared, I'm thinking that's already including the n squared to iterate over every kind of top left corner of the inner square that you're considering. So that'd be n to the 4th. So yesterday's answer, which was n to the 4th, is not doable here, I don't think. So I guess what you should probably do is you should probably be somehow optimized in what subsquare you're considering if you're kind of remove anything, right? So if you're considering a 3 by 3, it could be here or here or here or here or here. So those 3 by 3s, and maybe you can somehow compare this column versus this column and say that this column is better to be removed. Does that work? Does that work in the sense that that's always going to give you the best answer? Just comparing your kind of marginal deletions to see which deletion is better. I feel like you can get to some bad, it's a kind of a greedy approach. I don't know if that greedy approach always works out. So for instance, if you have a 300 by 300 and you're trying to get, and it doesn't work, then you're trying to get to 299 by 299, and maybe you're comparing deleting the leftmost column versus the rightmost column, or the topmost row versus the bottommost row. Does that always work to do that comparison? Can you end up being in a suboptimal subsquare, using that greedy approach? I kind of almost want to say that the greedy approach might be fine. But then, like, what do you do at the start? Because there might be multiple starting points. Like, there's a 3x3 here, 3x3 here, 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 here. Maybe your starting point. Greedy, greedy, greedy. You delete, you delete. What if it's a tie as well, right? Like, how do you know which to delete if there's a tie? If it's like one's on the left side and one's on the right side. Feels like you definitely can do something wrong in that case if you just delete both or delete one. Huh. 1, 1, 1. Is there some sort of way to just calculate it all? Binary search here, would that work? Binary search for the answer. It probably doesn't work. It's still too hard to determine in one pass if some value works. One, two, three, four, five, 6. 3x3. I mean, you could do a prefix array for each row at least, to make the calculation of some subarray within the row faster. Or you can do it with the columns to make the subcolumn faster. Under 300 by 300. Some subcolumn. I guess I don't care about diagonals here, right? Why would I care about diagonals? It's probably just too complicated. Okay, I'm going to start by just doing prefix rows and prefix columns just to make it easier to sum over certain elements of the rows and columns. So prefix rows equals an empty array. Let's go ahead and define rows and columns as the size of this matrix. Length is this number of 1D arrays in this 2D array, and then that's rows, and then length of matrix at 0, which is the first column, is going to give you the number of columns. So matrix at 0 is the first row, which gives you the length of that's the number of columns. So here prefix rows is going to, for every row in the matrix, send pre-row is going to be equal to an empty array. No, actually it starts with 0. And then for every column value in this row, pre-row appends pre-row at the last element plus the element plus the value of this column. And then prefix rows appends this pre-row. Go ahead and print this pre-row. This is very similar to yesterday. Identical to the starting of yesterday. So the prefix sum for the, that's not right. I want to actually print out the whole prefix rows 2D array. So for the first one, it should be 0, 2, 2 plus 3 is 5, 5 plus 2 is 7, 7 plus 4 is 11, plus 3 is 14, plus 2 is 16. Right, that looks right. 0, 1, 2, 5, 7. Right, so then let's go prefix columns. Every column index and range of the columns. Row index and range of rows. Recall. Recall -1 plus the element at this row column. And then here. So it should be 0, 1, 2, 3, 0, 1, 2, 3, 3, 6, 9, 2, 4, 6. Okay. Okay. Now to sum things up. If I were to, so it's 7 by 3. Biggest the answer could be would be 3 by 3. By 3. Maybe it is doable, just brute forcing it. Because it's going to be one pass to check if the 3 by 3 works. So it's going to be like 1, 2, 3, 4, 5, keeping some sort of running total that adds the next column and deletes the last column. So it's like 5. Then the next one is going to be 2 by 2s. Two by 2s. So that would give you n squared, I think. There's 1, 2, 3, 4, 5. And then it's going to be 1, 2, 3, 4, 5, 6, 12 2 by 2s. And then you have how many 1 by 1s? There'd be like 6. That'd be 7 times 3 is 21. That might not work. I think that might be too many. By 2. Divided by 300. So there's going to be 1, 300 by 300, and then there's going to be 4, 299 by 299, and then 9, 288 by 288, or 298 by 298. Yeah, it scales too much. Scales too much.